otherwise I will give the name. Vedant, you will do the first one, diode voltage and current
Okay,
related. Yeah. So whatever the just basic equation is it is the diode equation. Okay. So from the diode equation
अब
also you
एक्चुअली
can
क्या है कि
just
बीजेपी थोड़ा ज्यादा पावरफुल हो
derive
गई
2-3 more
क्योंकि
formula. Like
और
suppose
उसको
maybe question
120
will
से
be there
200 आरटीआई में
where
संशोधन
you
कर
need
दिए
to
मतलब ये
calculate
तो
the
दिन दहाड़े आप
voltage.
बेवकूफी
Current
बना
may
रहे
be
हैं ना
given.
कुछ
You need
ज्यादा
to
हो सके
calculate the
कांग्रेस के
voltage.
पास 40 गो
Or maybe it may be voltage current may be given. You may
में
ask
संशोधन
to
कर दिए
find the
मतलब ये तो दिन दहाड़े आप बेवकूफी बना
that
रहे हैं ना मोदी जी आप
reverse
पहले के
saturation
लोग को लोल
current.
समझते
Or
हैं
sometimes
ऐसा नहीं
what is the
आरटीआई का
value
मतलब होता
of
है
the
राइट टू
eta which
इन्फॉर्मेशन
diode is used that you need
आरटीआई
to
में
find.
मोदी जी ने संशोधन
So
किया था
in that
मार्च
way
में
you can
और अप्रैल में घोटाला हो गया पीएम
you
केयर
can
फंड का
generate
पीएम
3-4 more
केयर फंड
formula
का
also.
क्यों क्योंकि
Okay.
आरटीआई
So
में जब मनमोहन
like
सिंह ने
if
आरटीआई लाया था
required then you
2005
can
में तो उन्होंने
enter
कहा
more
था
rows
कि
there and you
आरटीआई
can
जो
do
होगा
it.
आरटीआई
So
यानी ये
first part
प्रधानमंत्री के कार्यालय
Vedant
से
will
I'll
बाहर
do it,
रहेगा
ma'am.
वो
Yes,
स्वतंत्र
ma'am. Yes.
रहेगा जिस
yeah.
तरह से सुप्रीम कोर्ट हाई
Ma'am,
कोर्ट है वैसे
I have to
आरटीआई
do it
रहेगा
right now
मोदी जी
today,
हैं
or
उन्होंने
it
कहा
can be
कि
done after the quiz.
Just
आरटीआई
after the class you do it.
ट्रांसफर सैलरी
So
Okay,
that
ma'am.
प्रधानमंत्री दे
hello.
देंगे प्रधानमंत्री के अधीन रहेगा और जब विपक्ष ने
हाँ
हंगामा
एक्चुअली
किया तो
क्लास
उन्होंने
चल रहा
कहा
है कि
कि ये
तब
तो
बात
सुधार
बाद
के
में
लिए किया
बात
गया
करते
बारे
हैं. हाँ हाँ. So just after the class you do it. So before quiz you all have a set of formula. So it is because half an hour time is very less time. So before that if you just recall the just revise that formula then you can quickly solve the question. That is my objective. Okay. So next part who will do?
The voice was disconnected due to some network issue. Can you repeat what you just said about the formula?
Yeah, just I am repeating. Just let me share the screen. Yeah, so just I have created one Excel sheet to that file will be accessible to all of you. So you if you voluntarily some students will do that, then everyone get benefited for overall gist of module 1 you can have in a very less time you can just go through it and it will be helpful for your quiz also. So Vedant will do the first one that is diode voltage and current. So whatever the formula related to diode voltage and current he will fill here. Okay. So next is diode resistance. Who will do about the diode resistance? Anyone you can just voluntarily you can give your name.
Anubhav.
Anubhav. Okay, Anubhav. You do it for the second one. Okay, so whatever the dynamic resistance of the diode, those you just write down. Okay, so for the silicon diode or for the germanium diode, maybe by putting the value of the eta, the resistance formula may be little bit different. So you just make 3-4 formula for this diode resistance so that any questions you can attempt very easily.
पागल
Okay.
समझ लिए और हम
Next part,
बात अलग
diode
है कि आपके
temperature
भक्ति में लोग
temperature
ज्यादा विलीन
dependence
हैं
of the
लेकिन
diode. Who
मोदी जी
will do?
जिस रास्ते को आप दिखा के जा रहे हैं ये रास्ता लोकतंत्र की तबाही की ओर जा रहा है क्योंकि जिंदगी भर आप प्रधानमंत्री नहीं रहेंगे खूब से खूब रहेंगे 2029 तक रहेंगे
You are reading it right now for the quiz, so it is not an issue. It will be beneficial for you.
You can assign
Yeah.
everyone. Everyone will listen to you. You can say.
Okay, sure. Actually, I want that who are coming from. I want to know the name. In the class, it is easier. In the offline class, it is very easier. Those students who are active, they are distinguished. So it depends upon the students. Okay, anyway.
Ma'am, in diode temperature dependence, you have to write the dependence of saturation current on temperature.
Yes, obviously. It is the main factor.
I'll do it.
Okay. Basically, this temperature dependence is for the reverse saturation current. This is mostly it is affected. Okay. And next, transition and diffusion capacitance. Who will do it? Uh, any girl students? Why you are behind? Only one girl student voice till now I have just heard. So why you are not keeping your outside? I'm not getting who are the girl students. Okay. Anyway, Anushka, are you there? Okay. Gaurang
Yes.
Dixit.
Yes.
So you have to do the capacitance part, right?
Okay, ma'am.
Okay. And next part is your Zener diode. So in Zener diode, you have studied three conditions, different conditions. Okay. So for three different conditions, there can be many formula. Like if you are asking to find the range of resistance, then if the formula is known to you, quickly you can calculate. Otherwise, you have to go for the process and you have to find the value. Okay. Like in the Zener diode case, many formula can be formulated. So who will take the responsibility for the Zener diode?
Alokik.
Okay, Priyanshu, sure, good. Next half wave rectifier with and without filter. Okay, so with filter, what are the values of this VDC, BRMS, ACRMS or BRRMS, whatever we are saying, and that ripple factor. These are the major formulas of half wave rectifier with filter and without filter. Both the formulas you have to take it in a single as a combined way so that it can be easily you can distinguish the formula. So who will take the
I would take.
harbor
Ma'am, I will.
and who what's your name?
Ma'am, Rushil.
Hmm?
Ma'am, Rushil. I will do it.
Rushil, sure. Harbor rectifier, you do it. Okay. And
Okay,
full
ma'am.
wave rectifier, full wave rectifier, full wave rectifier.
Ma'am, I will do the same.
No, any one more students should do it. Okay. So anyone else?
Ma'am, I will do it. Nikhil Verma.
Nikhil Burma. Okay, so just write the formula and you write your name also. Okay, in the just in the side of this topic, you just write your name so that we can actually. It's my common practice that when you will be in the offline class, actually I remember all those names. Okay, when I get I can remember all the whole class students' name. So I want that. So it creates a more belongingness to the students. Okay. So I want to know those names, those who are interacting. So it is better we should have an interactive class. Okay. Okay, so let's. So after just completion of the class, it will take hardly 10 minutes to you people. So you just complete this so that it will be very easier for you when you will do the for the quiz test. Before just the quiz test, you go for the formula and you can solve the question very quickly. Because little bit actually from the this basic electronics course, usually first two modules usually numericals part is more in the first two modules, and it is little bit difficult in comparison to other modules. So there are many variations can be possible in the questions. So we should
Excuse me, ma'am.
little bit yes.
Ma'am, in the like in the capacitance part, we'll just write the two equations right now for the one you gave in the class for transition and diffusion.
Yeah, in the book, if you're getting any more information also, then also you can do it. Okay, transition capacitance and
But only
diffusion
I think
capacitance.
mainly the theory part is there, like the book I have, bolstered.
Yeah.
Not much formulas in there. But
Okay.
the one you gave in the
So-
class, I'll write that.
Yeah, transition capacitance and diffusion capacitance. And also, if any other students, those who have not given their name, and you are finding that if any more informative things is there or any formula is left, then you can add it. Okay. Okay, so let's start to solve some numericals quickly.
Ma'am, will there be any questions from the temperature dependence?
Yeah, question may be there.
Okay.
Do you have that JB Gupta
अब
book?
एक्चुअली क्या है कि
You don't have that JB Gupta book, no? Actually, in that book, many examples are given from every topic. Actually, this JB Gupta book is it is having not almost all the electronics part, not only basic electronics. If any other electronics, actually, it is beneficial for the electronic students. So 3-4 subjects are covered here. So here, so many numericals are given. So it is beneficial to follow for the numerical part. Or I think one more thing, that transition capacitance and diffusion capacitance, this is not much more given in your Melvin Halkias and Boylston. I think very briefly it is given, na?
Yes, ma'am.
So
Yes,
I will post the pic of that from this book just after the class, so you can go through that concept also. Okay, like suppose questions, let's say. Like at what voltage the reverse current flowing through a germanium diode will reach 80% of its saturation. Value at room temperature. Okay, so here like we have the diode equation. Okay, so this saturation, it's 80% of its saturation value. That means the output current which is given, that is I, is your like 80% means what we can take 0.8 of your I0. Okay, 0.8 into I0, 80% of I0, but I0 is in the reverse direction and I is in the forward direction. So we can take this I is minus 0.8 into I naught. Indirectly the value of I is given here. Okay, so this is the current, it is given. Now we are having the current equation, that is I is equal to I naught e to the power b by eta vt minus 1. So this will give you the answer, like instead of I we can put it is minus of 0.I naught minus 0.I naught is equal to I naught e to the power v by eta vt. So at room temperature it is given. So at room temperature this vt value is 26 millivolt and it is given germanium diode. So eta value is 1 for the germanium diode. So if you put all this value, this is your b by eta vt. So this 26 millivolt minus 1. So from this I naught get cancelled out, and e to the power b by, we can say it is 0.026 volt. If you convert it into the volt, then this value is if you take 1 minus 0.8, this is 0.2. So what will be the voltage here? If e to the power this is your 0.2, then what will be this b by 0.026 that is log base E 0.2. This we need to calculate. So this voltage will be this, you calculate this log 0.2 and this 0. Multiply it by your 0.026. So if you calculate this, you can get 0.042 volt. This is the answer. So in this way also question may be asked. Instead of directly asking for finding the current or voltage, question may be little bit reverse way also. Okay. So this is one type of questions. So a germanium diode, just I am writing the data what is given. So a germanium diode draws 40 milliampere with forward bias of 0.25 volt. That means voltage is given 0.25 volt, forward current is given, that is 40 milliampere, and the junction is at room temperature of 293 Kelvin. Here temperature is given 293 degree Kelvin. Okay. Calculate the reverse saturation current of the diode. I naught you need to calculate. So obviously you can put the formula in, only the I naught is missing. So eta value is, as it is germanium diode, eta value is 1, that is known to you, and all other things are known to you. So instead of directly putting 26 millivolt in the VT, there we need to calculate, as it is given your 293 degree Kelvin. Usually that 26.
I'm saying the forward bias, we can neglect that -1, right?
Which one?
I mean the
Yeah,
forward
actually
bias,
it is.
neglect that -1. Like,
Yes. So in this type of questions, okay, usually when we take this 26 millivolt at room temperature, means whenever room temperature is 300 degree Kelvin, there putting that value, we have got that VT is 26 millivolt. But here temperature is given 293 Kelvin. So there you need to calculate the value of your VT, that is not 26 millivolt. So here we have to calculate that temperature by your 11,600. That by multiplying that Boltzmann constant and the charge of the electron, it is usually temperature by 11,600. So this VT you need to calculate, and after that you just put in that equation and you can find the I naught value. Okay, so here you will get the, if you want to calculate it, then just I am writing the answer. So I naught will come 2.0 microampere. This will be the answer. So you do it for calculation part, you can do it.
Ma'am, VT for germanium silicon both is same.
VT, yes, this one is same, because this is equation is B by eta VT na. This volt equivalent temperature is always T by 11,600, because VT is KT by Q. So this factor is this 1 by 11,600.
Ma'am, and I naught is reverse saturation current, right?
Yes, I naught is reverse saturation current. One more question is given, like a diode current is 0.6 milliampere when applied voltage is 400 millivolt. Means diode current is given, that is 0.6 milliampere, and voltage is given 400 millivolt, and 20 milliampere. Okay, and 20 milliampere when applied voltage is 5 volt. This is one set of data given. When current becomes 20 milliampere, then your voltage will be 500 millivolt. Okay, assume VT is equal to 26 millivolt. So find eta. Okay, this value is asked, eta. So how to calculate this eta? Here diode current equation is known to you. So from the diode current equation, we can find the value. So we will have
two values, two equations.
Yeah, we will two equations we will get. So one equations, from the one equation the values are coming, that is 0.6 milliampere, that is equal to your I naught e to the power 400 by 26 into eta. Another equation we are getting 20 milliampere, that is equal to I naught e to the power 500 by 26 eta. So here eta is unknown. Okay. So I naught is also unknown. So we can take the ratio. If you just divide these two terms, then we will get a single variable equation, and from that we can find the value of your eta. Okay, we can find the value of your eta. So you just try it. This eta value will be coming 1.097. Okay, so it is almost, eta value is we can say it is 1. So obviously the diode will be a germanium diode. Okay.
Ma'am, actually I had a doubt here.
Yes.
So ma'am, if we consider I naught as the magnitude of the saturation current, right? So
Yes.
while applying the formula that ID equal to I naught e to the power everything, so do we have to put the saturation current with sign or without sign?
Actually it is without sign, it is considered.
Ma'am, then in
Magnitude value
first question, ma'am, you have actually put in the sign. That is why I was.
Which one?
This one, ma'am.
Okay, this question.
Yeah, ma'am.
Yeah, actually here the current, whatever we are getting the current, actually indirectly it is giving 80% of the saturation current at room temperature. So actually when we need to calculate the forward voltage there, right? So for forward voltage calculation only we can consider this negative sign. That actually you can take it, I think it is without taking this negative sign also you will get. Here we will get the voltage in positive, it is coming in negative, right?
But then it will be 1.8, no? Instead of
Yes, ma'am.
0.2.
That is 0.2 instead of 0.2, it will be 1.8.
1.8.
One will be added over there.
Yeah, right. So part
Ma'am, I think it is taken with sign in the formula.
formula, but
Yes,
whenever
ma'am,
your
it is
calculation
with sign
is
because like
Ma'am,
I is the
because we
forward.
can explain both reverse saturation current value and the forward biased value with the same formula using the sign.
yeah, right. Actually this equation is basically for the forward biased condition. Okay, so when we are discussing about the forward biased condition and we are taking the magnitude of that as a positive. Okay, so like I naught is equal to suppose 40 milliampere we are considering, 40 microampere we are considering. That means automatically in the forward direction if you are calculating it in the positive means its value is in the reverse mode we are taking, na. So actually it is given taken as the with sign it is taken. Yeah, right.
So, ma'am, when will be negative and when will take it positive? Can you give us some?
Ma'am, this equation is for forward bias, and if it is reversed, then we will be taking negative.
Yeah, for the reverse bias it can be taken as negative.
Okay, ma'am.
Because overall current if you are finding, then the direction of the current, polarity means what? The direction of the current we are calculating. So if it is in the positive direction we are taking, that means the current is in the forward direction, that is we are considering. And negative current we are downward we are taking in the VI characteristics. So in the reverse bias it is usually current is in the negative. Okay, so one more question from this part. So a silicon diode has reverse saturation current of 2 point silicon diode it is given, and reverse saturation current it is given 2.5 microampere at 300 degree Kelvin. Find the forward voltage. That is V. Okay. For a forward current of 10 milliampere. So I is equal to 10 milliampere. So here simply the same concept will be used. I is given, I naught is given, only V is unknown. Okay, it is silicon diode is considered, so your eta value has to be taken 2. Okay, and at 300 degree Kelvin temperature, that your VT will be 26 millivolt. So by putting all this, again by taking the logarithmic of that part e to the power something we will get. So by taking log of that we will get the value of your voltage. Okay, so you just put the value and your voltage will be coming, answer is coming that This
And
B is
here ma'am, here it's not mentioned forward biased or reverse biased. So what we will consider it reverse, ma'am, because it is given reverse saturation.
no, reverse saturation current is the by default it is present. Okay, so
Yes, ma'am. That's why I'm asking.
yeah,
What we will
only
we will
you have to consider this point to 2.5 only. This one, this
okay.
value, not no negative sign will be there. So I naught value will be considered this one 2.5 microampere. Actually, this is the direction. The sign is for the direction. To this when we take the PN junction, this reverse saturation current, like if you consider this we are considering the majority current like P to N. If you are taking, so the majority current direction will be from P to N. Okay, and minority current directions, which will be the direction for the minority current. So from electron to electrons from the P, they are moving to the N side, and holes from N, they are moving in the P side. So the direction of the river, this is suppose majority current. Okay, majority current. So minority current direction, which will be the minority current direction?
Then it is forward bias or reverse bias.
And that
Like-
will get to know after you find the value of V. It is positive. or negative.
You just forgot about the biasing now. Okay, forgot about the biasing. Just I am telling that this direction of majority current, okay, which is basically in the forward biased we are considering. Okay, so this direction will be from P to N because it is the opposite to the movement of the electron. The direction will be, so the majority current, which is the majority current in forward bias, this direction is from this to this. In reverse bias also, whatever the biasing we are giving, that is other thing. Okay, but inside the diode, the direction of minority current means due to the minority charge carrier. So minority charge carrier in P side is your electrons. So electrons are moving from P to N, and holes are moving from N to P. So the minority current direction is in this way. I minority will be from N to P. Okay, so this is the basic. So if you are doing the reverse biasing, like P side is negative and this side is positive, so obviously the minority current will flow in which direction? Obviously in the circuit, it is the current direction is just the opposite. That's why we take the negative current. Okay, actually this current is in this way, the current is flowing. Okay, so we take it as when we consider the characteristics, we take it in the opposite direction. Okay, so anyway, so this is, so we are having very less time, so we will touch all the type of numericals so that you can solve it. So here you can find the voltage by taking the logarithmic value.
Yes,
So
ma'am.
the answer will be 0.43 volt. Okay, this will be the answer. You check your answer.
Ma'am, and here also we'll take opposite signs for I and I naught, right?
Where?
Ma'am, here, because here we are also finding, ma'am, VD, voltage across the diode.
You just don't think much more about that. It will create more confusion. Simply you just remember your equation I naught e to the power b by eta vt minus 1. Okay, forget about the direction here. Okay, just this unknown you need to find. This unknown value you need to find. That's much when you solving the numerical, don't confused about the sign. Okay.
Yes, ma'am.
Yeah. Okay, so this is about the diode equation. Some numericals. There this kind of question may be asked. Okay, and some more questions we can solve. Okay, so from the rectifier part, directly if it is given like your VDC, IDC, these things we can do. So from the diode also some question may be asked like your diode connection, how they are getting connected. So from that diode connection series, some connections also some questions may be there. So basically that is also the rectifier. But we can have that in the diode connections, like suppose your question is given like this. Suppose this is a silicon diode, another silicon diode is connected, this is the load. let RL is equal to 7 kilo ohm. So this is also a silicon, this is also silicon diode. So here the applied voltage is suppose 15 volt. Okay, suppose 15 volt applied voltage is there. So what will be the output voltage? V naught here. So how to calculate this? Simply you just check the diode is forward biased. Both the diodes are forward biased. You can replace it by your 0.7 volt supply. This is 0.7 volt, 0.7 volt. P side positive, N side negative, and this is load RL.
Ma'am, no resistance is provided.
Yeah, if resistance value is given, then you have to replace the diode with its equivalent, that is a voltage source, one resistance also. But here there is no resistance data is not given. Okay, so here we can take this 15 volt, simply apply the KVL, and you can find the voltage, that will be your
13.6
volt. Okay, sometimes the question may be some shunt connection may be there. Okay, like suppose the question is given like this. Suppose the 15 volt supply is given and two silicon diodes. One is silicon diode, another is germanium diode. This
Then
type
it will
of
go through
connection.
germanium diode.
Yeah.
You
This
have
is the
given
load.
us this one.
Yeah, because the germanium diode is having both the diodes are forward biased, but the germanium diode is having 0.3 and this is 0.7. So this germanium diode is having less resistance. So earlier it will be providing the path. So this silicon diode will be removed and simply the path will be followed. That is this one 0.3 volt, and this is 15 volt supply is given, and this is the load RL. So the current will pass through this. Okay, so this 15 volt, this type of connection is given, means this is not a single point, actually it is given like this type of connection is there. Okay, already one point is grounded, so you can take a closed loop also. Don't get confused, it is an open loop, it is a closed loop. Whenever in a single point voltage is given, means with respect to ground that voltage is applied. Okay, sometimes in some questions like यहाँ पे suppose लिखा हुआ होगा -15 volt. It means that suppose एक सर्किट में यहाँ पे हम लोगों को लिखा हुआ है just -5 volt. Okay, and suppose the circuit is like this, and here load is connected. Okay, it means that this -5 volt means the connections when you make the simplified loop. Okay, simplified loop, that's mean negative terminal of that battery is connected to this point. Okay, this is the 5 volt. So actually this kind of connection is there, so accordingly you just arrange the circuit and make the loop.
Ma'am, we are neglecting the silicon diode, or we can also calculate by V1 V2 divided by V1 plus V2, ma'am. So across voltage we can calculate.
No, actually when we calculate this switch, it is a switching circuit, na? So when the current will reach to here, through which path it will go? Obviously through the less resistive path it will go.
Okay, ma'am.
Ma'am, what if we use both silicon diodes or both germanium diodes?
If both are silicon diode, then either of the path you can choose. Obviously one that will be similar. Okay, if you are taking two parallel connections, then what will happen? अगर तुम लोग स्विच याद करो, अगर कोई भी स्विच घर में लगा हुआ है, पैरेलल कनेक्शन है, that means suppose the same bulb you have connected to two parallel switch, one is inside the room, one is outside the room. When we are coming outside the room, then also we can switch off that switch. Okay, that kind of thing. In one path, any one path it can follow.
Ma'am, just one question from this one.
Yes.
If we have been asked that what is the current in silicon, we have to straight out say zero, ma'am. in this question, GE and SI, where both GE and SI are in parallel, then we have to consider that if we have been asked is the current in SI, then we have to say zero, na ma'am.
Yes, yes, yes. That is zero.
Excuse me, ma'am.
Yes.
Ma'am, if instead of germanium there was silicon diode, two like that, when Roshan said that two silicon diodes will be there, and if we had to say what current is flowing through one silicon diode, so we will say I by 2 or I, just because both can function, so current can be divided also.
I by 2 will be there. Voltage drop will be same. So the like one question is there. Just I'm looking for that question.
Okay.
Ma'am, you did in the notes.
Yeah, question is there. Your circuit is, suppose this is 3.3 kilo ohm. One silicon diode is there. Another silicon diode is there. Okay. So here the question is like this. The load is connected here. Okay. So in this case, both are silicon diode. This is also silicon. This is also silicon. So yeah. Suppose this voltage is given 10 volt, and here the current is I, here the current is I1, here the current is I2. Okay. So and the I1, ID1, I1, I2, I, all the three currents, and what will be the output voltage B out we need to find here. So in this case, this B out or the output voltage will be simply your 0.7 volt, because this is 0.7 volt. So B out is simply 0.7 volt. Okay, and this I what will be about the current? So I will be equal to for this current. So at this point, what is the voltage? 0.7 volt. Okay, at this point voltage is 0.7 volt. Here you can apply the Kirchhoff's voltage law. So this is 10 volt minus 0.7 volt divided by your resistance. Okay, that is your 3.3 kilo ohm, na? 0. How much current it is? 0.33 kilo ohm it is given. 0.33, not okay. So 0.33 kilo ohm. So we can say it is 0.33 into your, we can take 10 to the power 3. So this will be 330 ohm. Okay. So diode resistance is neglected here. So this value is coming around 28.2 milliampere. So once you got this current, I is equal to this. Now this I1 and I2 both will be same, because this is same silicon is there. So this I1 is equal to your I2. So this I1 is equal to I2 is how much? Obviously it will be I by 2. So this is 14.1 milliampere. Okay. Okay, so this is, yes.
I'm going to give some question on the AC load line. Like AC load line is not much about that is there in the book.
Yes, ma'am.
Okay, let me see.
Ma'am.
Yes.
Ma'am, I have a doubt in this question. Actually, no current will flow through that load line, through that load, V out load.
Just 1 minute.
Yes, ma'am. You also
actually, actually what happened here, the diode we have considered that is very low resistance path you have considered. So here approximate analysis, just let me check. Approximate analysis it has taken. So this is where low resistance path of the diode, this resistance is, if it is very higher, then only 0.7 volt drop is there. So theoretically the current must be there, but practically it is taking that this two current will be having equivalent, but it should be calculated. If resistance value will be given, then it should be calculated. Actually resistance value, I think it is not given in the questions, that's why it is not calculating. So if resistance value will be given, then simply we can calculate that current also from 0.7 by this resistance value. So some current will must flow here also. So this will be I will be equal to I1. So again loop analysis we have to do. This is I1, I2 plus this amount of current. So you can calculate this resistance value. Actually in this particular numerical, this load resistance is not given, only the diode is considered, so that's why it is taken I by 2. Otherwise the current load current I need to calculate. This will be
Ma'am, but
0.7 by
diodes have no resistance. More current will be flowing through the resistance because there is resistance and why it will take.
Hello, I think someone has unmuted. Please mute yourself. It depends upon the resistance of this. If it is a higher resistance, obviously, if it is more than the diode resistance, then obviously it will choose the low resistance path.
Yes.
The current will choose the low resistance path. If the resistance value is given and if the resistance is more than the diode resistance, so in that case the current will not flow through the load. Okay, so let me find some question from the load line.
Ma'am, can you do one numerical solving tomorrow as well, so that for end we are more prepared?
Yes, we can do. We can do much more numericals tomorrow. There is no issue because this first module only it will take much time because there are various students are leaving and they are entering, so we have to go slowly. Now you are also acquainted, so we can little bit move faster, and the basic fundamentals is if it is known, then rest part we can cover up it in very less time. So we will able to get much more time also. And if required, then we can take extra class on Saturday also. There is no issue. So we can take extra class after the quiz. Actually, this duration is very short. Previous year also this class was started from November 30th. So we get almost 1 month more time. But this year it is already late, and from January it has started, and up to March 25 we have to complete. So that's why we are moving faster and we are not getting time. Otherwise there is sufficient time, we can do it. So there is no issue. If required, then I can take the class Saturday or Sunday also. If you people had no problem, or we will not make the attendance mandatory for that class. Those who will be interested, they can attend the class and we can discuss more problem also. So tomorrow class also we will discuss some problem. There is no issue because in end semester there is going to be lots of questions from this topic. If it will be the online exam, then 80 questions has to be given. 80 to 80 questions. So you just believe that from one module we have to frame 20 questions or approximately 20 questions. So if it is 20 questions, means it is lots of possibilities are there which question has to become. So we will little bit more focused on numerical for the first module. Okay, so this for calculation of the dynamic resistance, okay, when it will be given that dynamic resistance, like calculate the dynamic resistance of a PN junction diode for a forward current of 2 milliampere. यस मैम, हाँ मैम क्लास चल रहा है, थोड़ा मैम आपको 5-10 मिनट में कॉल कर रहे हैं. हाँ मैम. Okay, so you have to find the dynamic resistance of PN junction diode at a forward current of 2 milliampere, and KT/Q is given 25 millivolt. So you have to calculate the dynamic resistance. That is RD. Okay, that we need to calculate. Here it is given KT/Q is 25 millivolt. 25 millivolt, and forward current 2 milliampere, I is equal to 2 milliampere it is given. So here we need to calculate the dynamic resistance. So dynamic resistance actually 26 millivolt by I, that is by some approximate analysis we do that dynamic resistance. Actually this dynamic resistance, if you take this eta Vt by your I. So here Vt value is, you can calculate the Vt, you can calculate the eta value. If it is silicon diode, which one it is given? Germanium diode it is given, so eta value is equal to 1, and Vt value you can take, it is 26 millivolt it is given, and I value is given to you. So within using this formula you can calculate this dynamic resistance. It will come 12.5 ohm by taking eta is equal to 1. Okay. Then one more question from the dynamic resistance, like calculate the let me take. So if 5 minutes will be extended, then there is no issue. It is 10:50.
No issue. Class. No issue, ma'am.
Let's 5 minutes more. So we can just I will just write some questions. Two questions from rectifier. So one questions. Calculate the dynamic forward and reverse resistance of PN junction diode when applied voltage is 0.25 volt, temperature is given 300 degree Kelvin, I naught is given 2 microampere. So dynamic forward resistance we need to calculate, that is, so this R value will be eta Vt divided by I naught e to the power V by eta Vt. Okay, so this value will come 0.867. This is the forward resistance. Forward resistance. Okay. And for reverse resistance, usually for reverse case, reverse resistance, simply it is the output, the applied voltage divided by your reverse saturation current. So 0.25 divided by your 2 microampere 10 to the minus 6. So this value is 125 kilo ohm. Sir, good morning, sir. कॉन्फ्रेंस यस सर. हाँ मैम से हम बात कर लिए सर, उसको आज बना लेंगे. उसको मैम से जाके मिलकर हम बात किए हैं उसका. अच्छा ठीक, आज ही मैं सर बना देती हूँ उसको. हाँ सर ठीक है. डीपीसी वाला आज, हाँ सर आज सेकेंड हाफ में कर लेते हैं मीटिंग उसका. ओ अच्छा तो ये है. अच्छा ठीक है, मैं अभी सर जस्ट मेरा क्लास और 5 मिनट में ख़त्म करके मैं बात कर लेती हूँ. अगर फ्री होंगे तो अभी फर्स्ट हाफ में ही कर देंगे, नहीं तो 12 बजे. ज़्यादा टाइम तो नहीं लगेगा, जस्ट खाली साइन करना है उसमें. अगर नहीं भी कोई आ पाएंगे तो भेज देंगे, नहीं तो साइन करने के लिए. हाँ ठीक है सर. Okay, so this is about the diode resistance. So only one or two more numerical I want to just brief you, like from the rectifier. Okay, so better in hurry I will not just writing the questions, just I am sharing this pic. Okay, it is solved example. So I am just sharing 2-3 numericals from rectifier. You just go through it. Okay.
Yes, ma'am.
Okay, so I'm sharing this pic. Okay, so you can leave now, and just I will post the questions just before 5:58, before 2 minutes. Okay, so you can just switch on your team before that. Also, you can get the question before 2 minutes. I will upload, and maximum 5 minutes can be given for submission. Okay, up to 6:35, I will give the time.
Ma'am,
Yes.
did you give those questions last day?
No, no, no. I
Uploaded?
have not given. I could not give because it was too late when I reached home, and it was difficult. So I've not given. So you can follow the examples, solved examples from book. So from the rectifier part and that capacitor, that filtering part, I'm just filtering, and that what that transition diffusion capacitance theory part. This files I'm just sharing. Okay, you go through it and do the Excel sheet. Just fill it just when you get time. So it will be better. Okay, so you can leave now.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, please share this document also.
Sure, sure, sure. I'm sharing it.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.